Hey everyone, how's it going? Can everyone hear me? All good? So this is a more technical talk, so hopefully it balances up what we've seen tonight. It's the idea, I guess. So my name's Daniel. I work at a company called Open Credo, a consultancy company based just around the corner, actually, in Southwark. And this is lessons learned the hard way with continuous delivery and containers. Okay? So 5-10 minutes. If you don't want to listen to me, totally appreciate. Go and get your pizza, switch off. These are the TLDRs, yeah? The container image becomes the single binary, the single thing in a continuous delivery pipeline with containers. Yeah? This is lost on some people, we've found. Adding metadata to the thing moving down the pipeline, the container image in this case, is super, super important. Yeah? And cultivating mechanical sympathy, as in understanding and sort of just enough the fabric you're deploying onto, is super important. You'll actually note that these things aren't really container specific when you think about it for a second, but I found containers have kind of really leveled these up in terms of us being aware of these things. I've learned some of this working on a bunch of client projects over the last 3 years. I've tried to put some of this in a book we've got coming out in O'Reilly, actually. It's a free book. It'll be available in a couple of weeks' time, hopefully, so you can download that one, follow me on Twitter, and I'll tweet more details. But in terms of setting expectations with clients, a lot of people look at containers, things like Docker, and just think, awesome. You know, I can carve up my architecture, slot it into a container, ship it. Yeah, brilliant. The problem is many clients' architectures are kind of a bit of a tire fire. Yeah, you know, if you have a successful business, things just get added on, the way it goes, yeah. And if you've got a tire fire and you try and divide it up in containers, you get this kind of thing, yeah. Tire fire in a container, yeah, which is not so good. And you notice down here, these people here in the consultancy business, we call them DevOps, yeah, that's that kind of thing. But this is true, yeah. You know, containers are not magic. That's one thing I do want to say here. It's obvious, I know, but it's worth saying. Containers at their core is OS level virtualization. It's been around for quite a bit of time, but you know, Docker has made it super popular. It's a way effectively to package and execute software. If you're used to RPMs, debs, you know, jars in the Java space where I come from, these kind of things. But as I mentioned, the container image is now your single artifact. Yeah, if you're building a build pipeline, you know, Jez Humble, Dave Farley talked about for years, having this notion of a single binary, a single artifact. You push down the pipeline, test it, make sure it's production ready. If it ticks all the boxes, it goes into production. We see people building artifacts like they've always done and putting them in the container at the end, which is not great, yeah? The container image, in my mind, is now the single binary that goes down through the pipeline. You have to excuse the diagram. I wasn't sure screen size, but this is from the book. You can see this later. On the left there, classic kind of pipeline. On the right, a pipeline we've taken for containers. The main bits of difference, really, are that if you're deploying onto a fabric, say Docker Swarm, Kubernetes, Mesos, or whatever, you need to be testing on that as early as possible. We'll see some people, again, running, say, Kubernetes in production, but using Docker Swarm in test, and you get different results, yeah? So this bit here, how you actually run your tests is going to be a bit different. You now need to package the artifact early on in the process, so no longer in the Java world do you build a jar, or if you're building a deb or whatever, an RPM, you want to build a container, chuck it onto Docker Hub, that kind of thing. And it naturally knocks on to local development. Now, locally, you need to know you're building in a container, yeah? Unless you're using Cloud Foundry, of course, then you can kind of just build packs and push it.
Which is the opposite.
Yeah, exactly, yeah. So that's a different discussion. You can chat to me and Dan later on about that one. But if you're doing like container native stuff, you need to be testing the containers locally. Now this opens up, and it's kind of where the success actually of Cloud Foundry lies, but if you do go kind of Docker native, it opens up a whole new world for many developers, yeah? You've got an OS choice. What do you put as an OS in Docker, in the container? How do you get configuration in there? How do you get your build artifact in there? And then there's a bunch of language-specific things as well. Java, JDK versus Java runtime. Many developers haven't been exposed to this yet. So the kind of newsflash on this bit is talk to the sysadmin people, talk to the operations team, they're your friend. And I'm sure I'm preaching to the converted. I think in this room, most of you are probably pretty sort of savvy with these kind of things. But many developers in big organizations, like Dan mentioned, they're a bit reluctant to sort of walk across the office to chat to the operations people. But containers bring this up to the forefront. You very much need to chat to these kind of people. The team, I should say, these kind of people. The team, I should say, chat to the team. Some people try and split and have different dev and test containers. The idea being they can put more tooling in sort of the test containers, more data, these kind of things. But again, the single binary artifact, the single container for me is super important. Yeah. It's easy to see configuration drift if you try and have multiple things. You know, try and have a test container and a production container, so don't do that. There is an interesting sort of proposal from Alexei around having an on-test thing. If you know Docker in terms of the syntax, they're on about putting an on-test into the actual Docker syntax. I don't agree with it all, but it's an interesting proposal in terms of running a container in a test mode, which is something to think about. I still like Jenkins. I know we've mentioned Jenkins a little bit tonight, and Concourse. I've played around quite a bit with a lot of them. Jenkins pipeline as code is super cool in terms of defining build pipelines in code. We use this in combination with things like Docker Compose to run up containers and run tests. In terms of testing, these are my sort of favorite things. I'll share the slides later. Obviously automate all the things. We're all down with that here, I think. Things like Rest Assured and Serenity are really nice for BDD and REST kind of assertions. We mentioned BDD already, which is awesome. Loving that. I would mention in containers, the big thing is doing static security analysis. Yeah? Containers expose a bigger attack surface. Yeah? You're putting an OS in your artifact that you're now shipping. Many developers are used to just shipping platform-specific artifacts. So things like Claire. Claire's an open source core OS project, does static vulnerability analysis of containers. Docker Hub's got their beta version free for doing these things, but container security in a pipeline, super, super important, bringing those NFRs forward. Metadata, vital yet again, and beware the latest Docker tag. Don't just use latest, always version your images, because the latest tag, the semantics are a bit wonky. So yeah, always version. Same with any kind of artifact, always version it. Metadata, super important. With containers, it's still a bit loose, it's still emerging. The microscaling team and the microbadger people, they've put together some interesting proposals around metadata for Docker containers using labels. So Gareth Rushgrove's involved, Michael Hasenblas, Liz and Anne from Microscaling Solutions, shout them out. They're coming up with a really nice way of trying to sort of standardize through the community ways of labeling metadata on your image as it goes through the pipeline, which is nice. So the final thing, just check the time, is mechanical sympathy. This is like super important, I think. So I do a lot of Java work. Java's kind of my native language, native programming language, and we really discovered a lot of kind of issues. The way Java runs, for example, the JVM, if you put it on, say, a 64-core box, and you've carved up that 64-core box into 64 C groups, 64 containers, and given each container one CPU each, like the application will only get one CPU, but the JVM will see 64, yeah, which messes up. It's a bug. It's been fixed in JDK 9, which isn't out yet. They're going to backport it to 8 as well, but it's still an open issue. So default JVM settings just go totally screwy. And if you're testing, say, on a non-like live environment, you won't notice these things, yeah. We only noticed a bunch of these things when we pushed to production. We used C groups to limit memory and CPU, and suddenly a whole bunch of issues popped up with the JVM, which is nice. Same thing with developers being exposed to these new things. Like the way you set memory, like mostly this is an operations thing, but we find developers doing it more now. And being aware that in Java, you don't just want to set the Docker container to the heap size, because there's more things going on in a JVM. You want to set it to encounter metaspace, there's some overhead. If you're doing a lot of threading work, there's a native memory overhead with threads as well. Whole bunch of interesting things like that. And finally, entropy. If you're doing crypto operations on a containerized host, you often run out of entropy. You run out of randomness. So it'll block. If you try to access dev random to do crypto operations, which happens all the time in modern apps, session generation, these kind of things, the apps will just freeze. So we saw a bunch of apps starting up in production, just freezing. Bunch of them getting so far along, just freezing. Dove into the containers, had a look at the stacks, and it's because it's blocking on crypto operations because of entropy. So it's all about understanding and testing in your pipeline developing this mechanical sympathy, understanding the target fabric of where you're deploying. That's it, pretty much. If you want to know more, the book's coming out soon. There's a longer version of this talk I did at O'Reilly SACON as well. You can find online, I think. Thank you very much.